G'day everyone. So in my last video I disassembled the engine, and in this video I'm going to go through and individually inspect each component to see what work needs to be done and what parts I need to order. The reference material I'm using for all of this is the Haynes Yamaha 650 Twins manual, as well as the original Yamaha XS650 service manual. It's not the exact same bike, but this was actually my dad's bike in 1972 or something like that, and he just kept the manual. But these things are invaluable. So this manual here just assumes that you don't really know what you're doing, and there's a lot of things that it just tells you to go to a professional for. Whereas this one tells you exactly how to do everything, right down to pressing apart the crank and truing the crank. So it's invaluable. If you can get your hands on one of these, I highly recommend it. Alright, we'll start off with the rocker box. The rocker box has 4 rockers, as you can see here. The main thing we want to look at with these is the contact points of the cam here. These bits here act on the cam lobes, and we want to make sure that they're not scratched or scored or pitted or anything like that. These ones seem to be in very good condition, so I'm happy with that. Right, so the next thing we want to look at is the rocker pivots, and they are located underneath these screws here. Right, now inside there, these holes here have sleeves in them, which stop the rocker pivots from coming out, so we need to knock those out. Alright, you'll see these sleeves have shoulders on them, and there's an O-ring, so you don't want to lose that. Right, when we disassemble the rocker box, we want to make sure that the rockers and the rocker pivots all go back in the exact same place that we took them out of. The way I like to do it is I orientate the rocker box on the bench like this, back facing towards me, front facing away. Then I'll just take these components out and place them down in the exact same orientation next to it. Then once I've inspected it all, I can just put it all back in the same place. Alright, to get the rocker pivots out, use a 6mm bolt, screw that down into the end of the rocker pivot, and they should just pull out like so. Alright, remembering we want to put that back in the same place that it came from. So we'll place it down there. This one doesn't want to move. I got it. Alright, so now we'll check the condition of the shafts. We want to make sure there's no scoring and obvious wear marks around there. These ones seem pretty good. And we'll check the clearance inside the rocker itself by trying to rock the shaft. And there should be very little to no movement. These ones seem to be in very good condition. Alright, so I've put this through the vapor blaster and then thoroughly washed it and blown out all the oil ways with compressed air. And then I've just given it a deso bath to make sure that none of the steel on here is going to corrode. It came up pretty well. So now we'll put it back together. Alright, as I said before, these go back together the same way they came apart. So orientating this, once again, the PCV towards me, front of the rocker box away. And then I can just place all of this back in. and that's the rocker box done. Alright, next we're going to have a look at the camshaft and the cam bearings. Now there's 4 ball bearings on the camshaft. They're just a slip fit and they should just come straight off. Now what you want to do with these is you want to wash them out with a solvent. I've used a solution of diesel and petrol just to make sure there's no lubricant left in them. Then you want to make sure that they spin freely like so, and that there's no excessive play in the bearings. So that one's good. No gritty sound, spins nice and freely, no excessive play. So they're all good. If you do get any gritty sound and they don't spin freely, or you can visually see that there is a lot of sideways play in the center race compared to the outer race, they need replacing. Alright, so they're good. Next thing you want to have a look at is the cam chain sprocket. Make sure that the teeth are all nice and even and they're not starting to look like shark teeth and they're rounded off on one edge. These ones are good. It's pretty unlikely that this is going to wear out because it runs in oil anyway, but just in case, it's worth having a look at. And next you want to have a look at the cam lobes. You want to make sure that there's no pitting or scratching or dents in them. As you can see, these seem pretty nice and even. You can see there is a slight score in this lobe here, but it's very light and it's not going to affect the operation of the actual cam itself. The radiuses are all nice and even, there's no dents in them. So that's looking good as well. Alright, so before I pulled this engine out, I said that I thought the rattle was the front cam chain guide. But looking at this, I doubt this was the cause. Like there is a couple of little bits missing. Like, hang on, where are we? Like in there, and one up here. But I doubt that that's the cause. I'm going to order a new one of these anyway, because they're pretty cheap. This is the cam chain adjuster. It's basically just a plastic skid that runs along the chain and puts pressure on it. And that's got plenty of meat left on it as well, so that's not an issue. So I'll get a new one of those just in case, and I'll get a new cam chain just because I've already got it out and it's just nice to have a new cam chain. Alright, so now we're going to inspect the cylinder head. To inspect the cylinder head, we're going to need a valve spring compressor. This is just a dodgy one that I've made up out of a 6-inch G-clamp, piece of plate steel with a hole drilled in it like that. So the first thing we're going to do is we're going to remove the valves. As with everything else, we need to remember exactly where these valves came from and put them back in the same place once we're done. Alright, to remove the valves, we'll compress the valve springs. Alright, once those springs are compressed enough, these collets should come free. It's a lot easier if you have a magnet. Just tip them out. So these are the collets here. And then we'll release the tension on the valve spring compressor. Right, on top of the valve springs, you should have a collar. You've got an outer valve spring, an inner valve spring, and then you should have a valve spring seat, which is basically just a washer. if I can get it out. There it is, the valve spring seat. Once you've removed all that, the valve should just fall out the bottom, like so. On top of the valve stem guide, you should have a valve stem seal. That's this rubber thing here. And to get that off, just gently pry it up with a screwdriver and it should just pop off. And we'll repeat that process on the other 4 valves. Alright, so now the head's completely disassembled, we can go ahead and clean everything and get all the carbon off before we go any further with inspection. Alright, so I've cleaned the head up. It's been through the vapor blaster and it's been decarboned. So now we'll get on with inspecting it. Alright, so the first thing we're going to look at is the valve seats. Right, the valve seat is this part of the port here. It's a 45-degree angle that seals against the valve itself. We want to make sure that it's got no chunks or scratches and that it's uniform all the way around. These ones look pretty good. If there is any chunks or scratches missing out, or any major chunks taken out of the valve seat, then they'll need to be cut. Alright, so the next thing we're going to measure is the valve stem diameter. Now you've got to pick a spot on the valve stem that runs inside the valve guide. It's pretty easy to pick, it's a lot shinier. So just pick somewhere down here. Now you're going to need a micrometer. The only one I've got is in Imperial, but I've got the Imperial specs. And for the inlet valve, it's got to measure between 0.314 and 0.3146 of an inch. So let's give this one a crack. All right, and that's about 0.3145. So that one's good. For the exhaust, it's got to be between 0.3134 and 0.3140. And that's about 0.3136. So that one's in. Alright, so now we're going to measure the valve stem to valve guide clearance. To do this, just put the valve back in the valve guide, pull it up to its full extent, and then put a dial gauge on it and wiggle it backwards and forwards. And the most you want to see there is 0.1 of a millimeter. And this is about 0.04 of a mil. So that's good. Alright, so that's the head done. The only thing I'm going to need to do to this is lap the valves and replace the valve seals. So I'm not going to reassemble it now. What I'll do is I'll box these parts up and label them so I know where they went, order the parts, and when I get them I'll lap the valves and reassemble it. Alright, so now we're going to have a look at the cylinder block and the pistons. So these pistons have 25 stamped into the top of them, which leads me to believe that they are the first oversized piston. Nominal size for the pistons is 75mm. The first oversize is 75.25. So that's what I reckon this is. Just to check, the best way to do this is with a micrometer, but I don't have one this big and I'm not about to go spend that much money. But you can get a pretty good idea with the verniers. So this one is 75.2 something. So that confirms that that is the first oversized piston. Just to double check, we'll check this one. and that is 75.2, 4 or 5-ish. So yeah, that's good. Alright, so the next thing I'm going to look at is the bore itself. Just ignore the flash rust. I cleaned it and then didn't protect it quick enough, but it's nothing a quick hone won't fix. So you'll see there is a visible line running around here. Now the reason for that is the piston rings only travel up as far as that line. So when the bore wears, they only wear below that. And a quick indication as to how worn your bore is how much of a lip, or if you've got a lip, here. Now, running the screwdriver along there, I can't feel any lip, which is a really good sign. But we'll do a few more measurements just to make sure. Alright, so the best way to actually measure the bore diameter is with an internal micrometer, but once again, I don't have one of those. But you can get a pretty good idea, once again, just by using the piston, which we already know the diameter of, and some feeler gauges in beside it. What we're mainly interested in here is the piston to bore clearance anyway. So this isn't a bad way of getting it. All right, so the maximum piston to bore clearance is 0.1 of a millimeter. And the greatest point of wear in the bore is at the top of the stroke. So what we'll do is we'll get a 0.1 of a millimeter feeler gauge, and if we can get that in beside the piston, then this bore is no good. Right, it's going to be pretty hard to demonstrate because my hand's going to get in the way, but you get the idea. Fuck yeah. Alright, so that's not going in there. And let's see what kind of gap we actually do have. Right, so that's 0.08 of a mil at the top, which is within spec. So the next thing we want to do is figure out what our bore taper is. And to do that, we'll take a measurement down this end of the bore, subtract this measurement from the top measurement, and that's the bore taper. Alright, so we'll start at 0.08 because that's what it was at the top, and see if we can get that in there. Look at that, 0.08 at the bottom as well, so the bore has no taper. Alright, so that is the cylinder block and the pistons inspected. By the look of it, I would say this has been rebored pretty recently. Being that it's already at the first oversize, there's absolutely no lip in the bore, there's no taper on the bore, so that's pretty good. The only thing I'm going to do with this, because it's already apart, is I'm going to give it a hone and a re-ring. So I'll order the parts, and when we get those in, I'll do that. Alright, now for the crank. The bottom end on these bikes is renowned for being pretty strong, which is a great thing because rebuilding them is an absolute pain in the ass, and it requires special tooling. So let's have a look at this one. The first thing we'll look at is the big end, which is the bottom end, the bottom bearing on the conrod. And we're going to look for side play. So to do that, we'll grab a steel rule, place it underneath the little ends of the conrods, push it all the way one way, line it up with a millimeter mark, and then push it all the way the other way. And the most side play we want out of that is 2 millimeters. And that is about 1.5 on that one. Let's have a go at this one. And that is smack bang on 2 millimeters there. So that is out of spec. All right, so the next thing we want to look at on our conrods is the little end, which is the end that your gudgeon pin goes through and holds your piston. All right, so this is the little end. Now the inside of these is supposed to be copper coated. You can see this one is pretty much nothing but silver. You can see a little bit of copper just on the outer edges, which means it's pretty worn. Alright, just after those tests, I'm already pretty damn sure that I'm replacing these con rods. But just for another test, we'll get a gudgeon pin, place it through the little end, and just see how much play it's got. And that has an absolute shit ton of play. So those con rods are stuffed. Alright, so we already know that we need to replace our con rods and our big end bearings. So now we want to check out our main bearings. We've got 3 rollers, one here, here and here. And then we've got a large ball bearing here. To have a look at them, you need to wash them out thoroughly with a solvent. I've just used a mixture of diesel and petrol to get all of the lubricant out of them, and then have a look to see how much play they've got, spin them around, see if there's any gritty noises and things like that, and if there is, they need replacing. So we'll just start with this one. Oh, there's a bit of play in that one, and it doesn't sound all that great, and it doesn't spin super freely either. This one's also got a fair bit of play and doesn't sound great. That one has the most play out of any of them. And you can hear it sounds like there's kind of a bit of grit in there. So that one's definitely gone. And then we'll just give the ball bearing a rock. That's got a bit of rock in it. And I'm not really confident with the way it sounds either. So it looks like we're up for a full crank rebuild. Realistically, if you're going to press it apart just to get the con rods out, it's a good idea to replace all those bearings anyway, because to do the con rods, only to put it back in and have a main bearing fail on you, would be absolutely catastrophic. So may as well do it all at once. Alright, so for this we're going to need to order 3 main roller bearings, 1 main ball bearing, 2 con rod kits with big end bearings and gudgeon pins. To rebuild a crank is quite a big job, and you require at least a 20-ton press, pressing jigs, a dial gauge and some V-blocks for truing. So I don't know, I guess most people out there would want to go get this rebuilt by a professional. I'm going to give it a crack myself. I've got a 20-ton press, and I'll just get the rest of the stuff together and I'll give it a go. If I don't get it right the first time, I'll just keep doing it until I do get it right. So yeah, looking forward to that one. Alright, so if you remember back to my last video, I said that the bike was jumping out of 5th. So I've got all of the components to the gearbox here to have a look at. So the first thing I looked at was the selector shaft. And basically what I did is I rolled this along a piece of glass to make sure that it was straight. I don't have the piece of glass here, otherwise I'd do it in front of you. But essentially, you just want to do that with it and make sure there's no wobble. So that was good. Next thing I looked at was the selector forks. The one thing that I immediately noticed was that this one is worn unevenly. You can see it's really gouged out here, but not here, which means it has to be bent, because that's contacting a lot harder than that. So I've ordered a new one of those. But while we're here, because jumping in and out of 5th is obviously going to cause damage somewhere else, or could cause damage somewhere else, I've had a good look at the selector drum, and there doesn't seem to be anything wrong with that, so I'm pretty happy there. But being that it's jumping in and out, 5th gear, this is the 5th pinion gear, and this is the 5th driven gear, and these are the selectors here. Alright, so your selector fork runs in this groove here, and it can move this gear backwards and forwards and engage with these two gears here like this. So when it goes into fifth, it slides this way, and these dogs engage with this gear, locking this shaft and this gear together, which will then turn the fifth driven gear on the other shaft. So if it's this one that's jumping in and out, you can expect there might be some wear on the corners of these dogs, or where it engages with the gear here. Thankfully, it doesn't look like there is any wear on this one. Right, so that's the fifth pinion gear. Right, so this is the fifth driven gear here, and when we're in fifth, it's actually sitting out here in between this gear and this gear, not engaged with anything. So all it's doing is turning the shaft, and these two are free to spin independently of the shaft. So it can't be this gear that's making it jump in and out, and there's no wear on any of its teeth or the dogs or anything like that, so I'm happy with that. Hopefully I'll get away with just replacing this selector fork. Alright, so this is turning out to be a much bigger job than I'd hoped. The rattle that I thought was the front cam chain guide, I reckon was probably the gudgeon pins rattling around in the little end. I can't really think of anything else it could be. If it was the bottom end, it would have just been like crazy vibration and rumble, so I reckon the rattle was that. But yeah. So anyway, I've done up a parts list. As you can see over here, I need valve seals, an engine seal kit, because I'd hate to get this thing back together and find a leak, so I'm not going to reuse any seals. I'll get all new seals. I need a new head gasket, a new base gasket. I need a new cam chain. I need 3 roller main bearings. They are expensive. In Australia, they're about 150 bucks a pop. So that's 450 just for the rollers. Another 100 for the main ball bearing. So that's, what, 550 just for the main bearings. I need 2 con rods. They come with big end bearings and crank pins. I need 2 new gudgeon pins because they were worn out, slapping around in the little end. I need 2 first oversized ring sets, the 0.25s, and I need a number 1 selector fork. I've probably missed something, but I'll come across it later. As far as things to do go, I need to do the valve seals. I need to lap the valves. Well, I'll probably do that before I do the valve seals. I need to hone and re-ring it. I need to rebuild the crank. That is a big job. So that'll be fun. And I need to fix fifth. So, to rebuild the crank, I'm going to have to make a few things. I've already got the 20-ton press. I'm going to need to make pressing jigs for the crank, and I need to make alignment jigs for when I put it back together to make sure it's all straight and true. So that is going to make for some interesting videos. I'm actually looking forward to making them. I'm not looking forward to paying for them, but that's just life. So yeah, thanks for watching, guys. I hope you got something out of it, and I'll see you on the next one.